Immunization is the fundamental process of gaining protection against disease, occurring primarily through two distinct paths: natural immunity and vaccines. Our bodies possess innate immunity from birth to fight invaders immediately, while acquired immunity develops over time following exposure to specific threats like bacteria, fungi, or viruses. It is the cornerstone of modern preventative medicine and global health. Vaccines serve as medical treatments that train the immune system to recognize and defend against pathogens, such as the bacteria causing pertussis or the flu virus. While no vaccine is 100% effective, they have revolutionized global health, making once fatal diseases like polio and diphtheria rare and completely eliminating smallpox, which was once a devastating threat to humanity worldwide. However, challenges remain as effective vaccines are still unavailable for several infections, including HIV, syphilis, Lyme disease, and the Zika virus. Notably, the World Health Organization now recommends the RTS/AS01 and R21/Matrix-M vaccines to combat malaria in high-risk regions, particularly for children in Africa, where the disease causes hundreds of thousands of deaths and significant suffering every year. There are two distinct types of immunization: active and passive. Active immunization involves using vaccines to stimulate the body's own immune system to produce antibodies. This method creates long-lasting immunologic memory, though it takes several weeks to fully develop. Active vaccines come in various forms, including inactivated, live attenuated, and subunit versions, each designed for specific types of pathogens. Other active vaccine types include mRNA, subunit, toxoid, and vector vaccines. Some even include adjuvants, which are additional chemicals that boost the vaccine's effectiveness by stimulating a stronger and longer response from the immune system. These diverse technologies allow scientists to target specific pathogens effectively, ensuring the body recognizes and remembers how to fight them in the future. Vaccines containing live organisms are used for a wide range of diseases, including measles, mumps, rubella, chickenpox, Ebola, and yellow fever. While these are highly effective, they require careful administration to ensure safety. Active immunization is essential for long-term health as it prepares the body to automatically produce defenses whenever it is exposed to specific bacteria or viruses later. In contrast, passive immunization provides immediate but temporary protection by giving a person antibodies directly. These antibodies can be sourced from animal blood, often from horses, pooled human immune globulin from large groups of people, or even lab-grown cells. This approach is critical for individuals who cannot wait for their own immune system to respond to a threat. Passive immunization is used for people whose immune systems do not respond adequately, or those facing immediate threats where there is no time for a full vaccination series. For example, it is used after a rabies bite, or when a pregnant person without immunity is exposed to the chickenpox virus, which could harm the fetus and cause serious complications. While the protection from passive immunization is instant, it is not permanent. It only lasts for a few weeks until the body naturally eliminates the injected antibodies. This makes it a short-term solution for emergency prevention rather than a long-term strategy like active vaccination, which builds lasting internal defenses that can protect a person for many years or life. Immunization remains one of the most important tools for personal and community health. Many vaccine-preventable diseases are easily spread from person to person and remain common in various parts of the world today. Through modern travel, even people in low-risk areas can be exposed, making widespread vaccination a vital global priority to prevent outbreaks and protect the vulnerable. The World Health Organization continues to monitor and recommend specific interventions, like the recent malaria vaccines, to protect the most vulnerable populations. By understanding the difference between active and passive immunization, healthcare providers can better choose the right method of protection based on the patient's health status, their medical history, and the specific urgency of the disease threat. Ultimately, whether through the long-lasting memory of active vaccines or the immediate shield of passive antibodies, immunization provides a critical defense against infectious diseases. It has transformed the landscape of medicine, saving millions of lives and continuing to offer hope for the elimination of more diseases through ongoing research, development, and global cooperation in the medical field. In summary, immunization is the process of becoming protected against disease through innate and acquired immunity or medical vaccines. Active immunization offers long-term memory, while passive immunization provides immediate short-term protection. Together, these methods form a comprehensive shield that protects individuals and communities worldwide from serious and preventable health threats, ensuring a healthier future for everyone on Earth.